Hi, in this video, we're going to take a brief look at the ggfortify package. All right, when I say brief, it's because ggfortify does a lot. It provides a lot of utility to us, but I feel like it doesn't really get a whole heck of a lot of love when it comes to, the R community. It's kind of sprinkled throughout and it's useful like all over the place for us to do like get a quick result really fast and easy that we can use to improve our situation. But it's not very specific. And so when we start talking about, a particular topic in data science, we focus on the tools that are specific to that task that we're on, and ggfortify tends to not really get talked about. All right, so there's two major functions in ggfortify that are going to be the focus here. First one is the fortify function, which is going to take an object and convert it to a format that modern users are probably going to want to have a more convenient format. And I'll provide plenty of examples of that. The other one is autoplot. Autoplot is really nice and quick to get me a decent visualization of what's going on, whatever the object is, with me not really having to do a whole heck of a lot of work. I drop the object into autoplot. Autoplot gives me an image. Boom, I've got something good. Now I can control and tinker with things because autoplot is built up off of ggplot, and I have the options of changing things, many of the aesthetics that are in ggplot. Now, ggplot is going to be more flexible, more powerful, more utility, but it's going to take more work. Another good use of autoplot is that if you don't know ggplot, but you want to learn it, to get used to the syntax and the way of thinking, autoplot is a good like baby step for this. All right, so if you've watched my videos, you know that I usually don't do a table of contents. In this video, I did because there's just so much utility in this. I felt like I just had to. All right, so here I went ahead and I grouped the objects that ggfortify supports. Using the table of contents, you can see it. So we've got time series, and you can see all the types of time series that are supported. We have supervised learning models. We have clustering. We have dimension reduction, spatial statistics, survival analysis, and then others. All right, this is what I found when I was going through the help documentation. There's other things that I definitely missed. There's a lot in here. Um, so chances are, if you have an object and you want to do a quick visualization, you want to fortify the object you're working on, ggfortify has got support for you. You'll notice that a lot of the time series are really well supported by this. Now, one thing about R is that R has a lot of different object classes for time series because of people creating different time series packages. Um, base R, the stats package, there's just like so many things dealing with time, so many things dealing with the time series objects that like we need to be able to convert to like a common format. The fortify function helps quite a bit with this. All right, so we're supervised learning. One thing that this does really nice for us is we can do quick plots, and we can set it up so that the data that I have that I built my linear regression model on, I can put on columns that I'm definitely interested in onto the data frame for further analysis. We can do that with generalized linear models, GLMNet. There's a bunch of stuff in here. We can also, get really quick diagnostic plots for using the receiver operator characteristic. Now for clustering, the ones I saw in the help documentation were for k-means, which is in base R, and then these three, which are in the cluster package. I think the entire cluster package, or almost all of it, is supported, but I didn't get around to it because you can see there's enough stuff in this video as is. Now for dimension reduction, we can see that the ggfortify supports the two base R ways of doing principal component analysis. So remember, friend comp is usually the one I want to use if I'm going to be doing like more analytical stuff, more psychometrics work, while the PR comp is numerically more stable than a print comp, but it doesn't offer by just a hair, it doesn't offer quite as much utility for analysis. But if I just need the principal components, that's it. It's perfectly fine. We can also do factor analysis. Now, spatial statistics supported also. It does some things that when I've worked on spatial statistics in the past that were kind of a pain in my neck that I wish I would have known that ggfortify, solved these problems for me at the time. Also, survival analysis. I don't have nearly as much survival analysis experience, but here are the objects I found in the help documentation. And then there's also, some utilities here and there. All right, so the fortify function extracts or converts aspects of an object to a data frame. That's typically what happens is that it's going to take something that we would be interested in and puts it in a data frame over and over and over. You'll see that. Um, Now notice that it just says that sentence I have highlighted, it's just an object. I can drop almost any object in R into Fortify, boom, it gives me a data frame, which is a nicer format for us to work with now that the tidyverse is in existence. Remember that R has been around for a long time, so some of the objects are not as they're not presented as consistently as things since like Hadley Wickham came onto the scene and since the tidyverse came into existence. In the tidyverse, we do everything with a data frame, and we have to have the right format of my data frame. So a lot of times we want to have it in like long format. Well, back in the day, before I was born, these objects, they created the objects for the problems at that time, not for problems in the future. And so I'll run the base R code, and then boom, I get something. But now I have to convert it to another format so I can start using the tidyverse to execute something. Fortify is going to be that bridge for me, quick and easy. Um, all right. The exact output of the fortify function and its relationship to the original data will depend on the object. So there's going to be some inconsistencies on this because human beings created this, but that's okay. This is a huge help to us. Now, to prevent too much output from being printed, fortify output is usually trimmed. And now, as we look through this, we're going to see a bunch of models. I'm not going to say, hey, is this a good model or a bad model? I'm just trying to show how does ggfortify work. Now, the autoplot function is the other major function in ggfortify, and it's a quick, fast, easy way to visualize a wide variety of objects. So I can just drop something in to autoplot, and I get a visualization. It's at least decent, and that gives, so now I can start working on it. Now, autoplot is based off of ggplot2 package. It invokes ggplot for us, and so a part of this, let's say that I'm new to ggplot, I need to use ggplot, but I'm uncomfortable because it does have the grammar of graphics has a different syntax. It's unusual. I see students sometimes having problems with it. Um, we could use the autoplot function to go and start learning the syntax of ggplot real easily. All right, so let's go ahead and start doing examples. All right, so I'm going to set up my workspace of having, don't get blasted in the face by numbers. Just, suppress the number of digits to 3. Avoid scientific notation. Now, something that I actually find annoying, and this is a complaint of mine, not a major complaint, but I prefer to not load packages because I've had problems with packages having functions of the same name. And when I call a function, I get what I call package confusion in that I intend to call a function from this package, but the function that's implemented is from another package. And so what I prefer to do, double colon notation. And so that is package name, then double colon, then the function's name when I do my function calls. This is similar to like doing np dot mean if I'm doing a mean with NumPy in Python. In Pandas we do pd dot data frame if using pandas and Python to help prevent this problem. Like Python has figured out this problem better than R. And I always like piping. I do a lot of piping. So I'm just going to pull that up. All right, so I'm just going to scroll through a bunch of time series things that we can get. And so first thing I want to do is I just want to show you the format of this time series data. And so this is the air passengers going from 1949 to 1960 over the year-month combination. All right, so for every month, every year in my data set, I have a number of airline passengers in this. This format, this all the data is there. Morally speaking, all the information is present, but it's not in a format that works with modern computation. All right, so the modern functions that we have are not set up to have the data in this format. This is a wide format. If I want to work with this in a more typical way, I would want to have the time in one column, and then I would have the number in another column. And so when I say time, I would have year and month in one column. All right, so let's do an auto plot. So one thing that's nice is that the auto plot for this, boom, I can see like what the plot has given me real quick and easy off of this. We definitely see an overall trend and we definitely see a seasonal aspect off of this. And using autoplot, I could go in and start controlling the axes. I can invoke a lot of ggplot to get a better plot, but as a first initial go, that's agnostic to whatever situation I'm in, autoplot does a really good job. Now let's take a look at the fortify. And so if I use the fortify function on this, you'll notice that it gets converted over to long format. So potentially what could have happened, I could have had the year, could have had the month, could have had the data on there. It did a good job of converting year and month to an actual date for me. You notice that it's assuming that the first of the month for each of these, I could go in and easily fix that if I wanted something different. Or, I could easily, convert this over to a string and just drop the last three entries. So if I want the first, if I converted to a string and did substring, first is 1, last is 7, you'll notice that I would get this year and month and not have, but I would no longer have a date object. So whatever works for your project. All right, so let's do another one. Let's say UK gas. I can do an auto plot. And so here, notice how I can just real easily, didn't have to work on it, didn't have to do anything, got a plot going. And here it takes the data and converts it to from whatever format it was in into a standard data frame format. Now, with multiple time series objects, MTS, there's actually a problem with this. In that here's my original data. You notice that I've got actually 4 time series off of this. When I go and I do my fortify, or I'm going to scroll a little bit farther down. Okay, it's a different, I misspoke. There's a different example I was thinking of. But you see that it just set it up so that it's in a more standard format. So how the tidyverse is set up is it does not like row names. So if you've ever worked in Python for very long, you'll get very frustrated with the index aspect. It doesn't let you let go of an index. I feel like I'm always fighting at work with an index for no reason at all. The tidyverse says, hey, we're not even bothering with that. We're not even going to worry about that. We're going to make anything that's important into its own column. And so here, this year quarter combination is effectively a row name or an index. And what Fortify does, it takes it out and puts it into the column, and it puts it in a better format for us. Now for my auto plot with the default settings, you can see that I've got all 4 plots, all 4 time series going on. We can definitely start picking up on trends on the first 3. I could also put faucets equals false, and now I have all those plots on the same axes. And so depending on what my project is, one of these plots may be better than the other. Now an XTS time series object is a relatively more recent package for time series. And so here is the original data. I can do my auto plot. Boom, I've got it. And I can do fortify. And once again, it sets this up for me very nicely. And it's basically just a repeat over and over and over of the time series objects. And now here we have an irregular uh, a space time series object. Yeah, so when it's an irregularly spaced time series object, that means that if I look at two consecutive observations, I have no guarantee of what the time difference between those two observations are. And so it just sets us up, figures things out for us very nicely. Now we can also do auto plots on our seasonal decomposition. So if I take this and convert to periodic and do the auto plot, boom, you can see I have it very nicely. I've got my data, I got my remainder, I got my seasonal trend. So here's my original data, here is my trend, here's my seasonal effect, and here is the remainder of what's going on. And Fortify puts everything into a nice data frame format. Also, can do this with a seasonal decomposition by moving averages. So once again, here I'm using the decompose function that we have in base R. I've got my data, I've got my overall trend, I've got my seasonal effect, and then we can see the remainder coming off of that. Fortify puts it into a nice data frame. All right, so we have our auto and auto covariance, cross covariance, auto correlations, and cross correlation functions also when we do time series objects. So let's go ahead and take a look at that. And so, Fortify, this is puts it out as a vector to make it, nice and easy to work with. Oh, yeah, and here is the confidence interval for ACF. So I did ACF. I want to get the confidence interval out. Boom, I've got it. Here's my confidence interval for my moving average. Here's the auto plot. And notice that, it puts the bars on there so I can do the interpretation. So we definitely have some significant autocorrelation going on. I've got everything spelled out in a data frame so I can easily extract this, easily do analysis on individual things. I can do visualizations that I might want to have custom. This is actually like really, really nice. This feature here to be able to take an object that it's normally not easy to get things out. I mean, I could just use the str function and find the structure and figure it out and find the slot. But you know what? ggfortify spits it out for me quick and easy. Partial autocorrelation function. First, I can get my confidence interval out. And I can get the partial autocorrelation aspect real easily off of this. And our cross correlation functions, once again we have utility. Autoplot gives me a decent visualization of the cross correlation function. All right, so now next one I want to talk about is a cumulative periodogram. All right, so here is the object I've got for the so this is coming from ggfortify, and I want to do a cumulative periodogram. That's abbreviated there. And I can just see the plot nice and easy for the interpretation. Go ahead and get ggfortify. Well, I mean, it's the same thing as I did previously, just to emphasize it. And now if I want to be able to do structure change package breakpoints on this. So here I set my breakpoints on the Nile data set. Here I have another one. So here I've just got a formula based on the constant. Here I've got two breaks, and I can plot the first one with auto plot, and boom, we can see that there's definitely, to my eyes, there are two different populations going on. And you can also do auto plot. Once again, put is date equals true. And so I don't see a difference in the plot, but I'm sure there is something. Um, Now here, the breaks column is always going to be in A unless it's a point where we have that vertical breakpoint going on. Now here in breakpoints now two, we had two breakpoints. And so, we can look and see we have that first one that we're very confident about. And then there's a second one here that I would have missed visually with my eyes. Maybe it's there, maybe it's not. We're not judging to see if this model is good or bad. It's just this is utility that we can pull out. All right, we can also do an auto plot to identify changes in means. So, I'm using a change point function, and we're trying to find a change point of the mean and mean variance. And so, we can just we can see that, it's capturing two different parts of that overall trend. I would say instead of change in mean, it's a trend is what I would be more focused on. Now here, I would say that there is more variance in this range. So here we're doing the mean variance, and this does look like it's greater variance here than over here. And notice that when I do fortify, it will give me a mean and variance estimate once it has enough data to do the computations. Now we can also auto plot autoregressive models. So here's a regular, as simple as possible autoregressive model that I'm going to fit. And so it just imposes it onto the plot. You can see that there's, a little bit of a difference, but it's doing a decent job, especially considering how simple it is. Now, this is where I really like Fortify to come in, that I have an object, I have my data, I have a model, I put it into Fortify. What it's going to do, it's going to take, so here's the original data, these two columns. It's going to put columns from my model onto the data frame that sets it up so that I can take a look at these very easily. I've got my fitted values, I've got my residuals. If I want to analyze the fitted values more, more precisely, I have it just sitting in this object ready for me to grab. If I wanted to analyze the residuals, which is a huge aspect of statistics, I've got it for me in an easy spot. I don't have to call some other, function. I'll have to figure out which function's available. Fortify does this for me very easily. Now we can auto plot an autoregressive integrated moving average model. And so, we can take a look at those roots and we can see where it is in relation to the unit circle. There's a bunch of things that we have available for this. We can look at the standardized residuals over time. It took an autocorrelation function of the residuals, p-values going off of this. And, once again, Fortify gives me data frame with the features of the model I would probably want to analyze. And we can do fractionally differenced AR, our FEMA model. And this looks very similar to what we've seen before. We can also auto plot neural network time series forecasts. Easy peasy lemon squeezy. So we've got forecast, neural network on this. And so we can do the forecast and take a look and compare our model to our predictions. Fortify does what we talked about before. We can auto plot Holt winter filtering. Now, something that we can do, we can also put on predictions on our time series, and we can predict into the future several steps. So here we're saying 5 ahead into the future, so we can see, using the model, anticipate what's going to happen down the line. And we can also include a prediction interval off of this, so I can see the range of what the model thinks is reasonable. And for Holt Winters, it's very nice in that it gives us predicted value, level, the trend, the season, the residual. It gives us a lot of information that I could dig into if I wanted to. Now, for a forecast, I can do, it's very much the same thing over and over and over. Now, here I'm doing an auto ARIMA model in the auto ARIMA. It figures out an ARIMA model that fits as well as possible. And so I can, just plot it. And, auto ARIMA gave me a 211010. And we can, specify how far out into the future we want. We can vary things, by quite a bit, have control over it. The thing that's nice about this is that it sets it up that I can get these visualizations without having to do a whole lot of work. Sometimes individual functions, to be able to get this stuff, it takes some work, takes some effort. Now, the fortify function, remember that on the left-hand side, for a lot of model structures, I'm not going to be able to have predictions on the initial values, and you can see that here with all the missing values on the right-hand side of the columns. And here I got the forecast. I'm basically just trying to show different ways to use autoplot, use forecasts, and use different types of functions or types of objects. So just rolling through this. So we also do autoplot, exponential smoothing, state space models with box Cox transformations, ARMA errors, trend, and seasonal components. This is towards the end of my time series course when I teach time series. Here's my observed, my level, and my slope. And you'll notice that ggfortify gives me all of those columns in a nice spot to work with. We can do spectral density estimation. And I'm getting kind of tired of talking about time series. It support Fortify, the ggfortify package really well supports time series. I think I'm getting towards the end now. Auto plot estimation of the variance of P. So we can just, get a look at it. Here is this point estimate lines. All right, so now let's talk about supervised learning. All right, so everything we talked about so far was just time series. All right, so since we've just been doing time series, I feel like I've ran that into the ground. We're going to start talking about some of the fundamental supervised learning models that are supported by ggfortify. The first one, of course, is the granddaddy of models, linear regression. All right, so if I do auto plot, this is very similar to the plot function on regular base R with a linear model. There's similarities, but this is kind of souped up a little bit in that if I put which equals 1 to 6, I'll get the same plots as I would with the base function. But what this does, by default, this puts it all into one big plot. And so that way I don't have like a bunch of different ones to scroll through. It makes it a little bit easier if I want to find the same, the same point on multiple plots. Remember that when I look at these, base R's plot function always labels the 3 most extreme every single time. That doesn't mean it's actually an extreme, doesn't mean it's an outlier, and it doesn't mean you only have 3 outliers. It just says it labels the most extreme 3 points every single time. And we can go through and see these and just look through. These are the fundamental plots that are in base R. We can definitely, take a look at this. See, hey, I'm a little bit above. So it looks like I may have like my residual might be a little bit right skewed. over here. And we can go through and just see what's going on. I see two different groups over here. So, definitely that's probably just part of the data itself, by the values you got, but it's something I would definitely want to investigate further. Yeah, and this section of the data definitely has more of the extreme values and Cook's distance. Definitely want to take a look at the later rows, see if there's something weird going on in data order. Now, I can also color. So this is where we start doing the ggplot, syntax. Notice that I didn't pass a full object. I just said a character string that's in the data frame. Now it goes through and it starts plotting things. And like you'll notice, hey, all the reds here, all the greens here, all the blues. Now this makes a lot of sense where I saw that gap before. And kind of look to see, do I see anything weird going on? Well, there's definitely a pattern going on in here in terms of the colors. We can see that here. Notice that I did not put which on here, right? Since I left it on just the default which, what's happening is that it's only showing what base R shows by default. If in base R I put for a linear model, which equals 1, 2, 3, 4, 5, 6, I'll get 6 different plots, and I can control which ones I see. I can just do one at a time if I want, and by default, there's only 4, so I can just drop things. And so now here, this is one of the things I really like about the fortify function is that after I have a linear model, let's say that I know that this is a model I'm going to use, I want to launch it into production, or I want to study it further to make a final decision. Well, these things, the hat value, the sigma value, well, the sigma is constant for linear models. Cook's distance, the fitted value, the residual, and the standardized residuals are all things that, as a statistician, I want to analyze deeper. There are functions in R that will extract this for me, but I have to call them individually. It's not too difficult, but when you consider the wide range of objects that I work with, Fortify like figures this out for me. I don't have to do the work. This is nice. And we can auto plot generalized linear models. So we also have generalized linear models. This one's a linear model. And I basically get the same utility, which is very similar to base R. There's a lot of overlap between those. LM does have more supporting functions than GLM, but not by much. Almost always, if it's a GLM or an LM, one function that supports one supports the other. And once again, we can go through and just see the things tacked on to the data when I use Fortify. I know it also supports GLM net. So you notice I'm doing a cross-validation GLM net object. And so I can see, and you might prefer this plot. This is basically a repeat of the default plot for GLM net. And we can, try to decide where do we think we should pick for our penalty parameter based off of this. And it gives us the same points of reference to look at. And when I do fortify, you'll notice that I get a data frame with values so I can actually grab it and take a look and be more precise in what's going on than just using a plot. And we can auto plot GLM nets directly. So that was a cross validation. And so here is the L1 norm, and here are the coefficients. So I can visualize what the coefficients are going to be for different penalty parameters. Or sorry, not penalty parameters. Here's off of the norm of it. And I can also visualize the lambda off of this. So here is the log of lambda, and here are the coefficients. We can see how they shrink as I increase the penalty. We look at the deviation, the deviance off of it. So fraction deviance explained. Here's the coefficients. And then, for the fortify, I can get the degrees of freedom, the lambda, the deviation ratio nicely. We can also look at Markov switching models. I have not used any of these models professionally. But here's utilities to support us to be able to execute and do stuff. And the Fortify does a good job of giving us the columns that I would want if I want to analyze more deeply. So we also do our receiver operator characteristic plots. Easy peasy lemon squeezy. I can see the plots. And one thing that's nice about this is by default, it shows us what the cutoff is with the color. Now, it is hard to read, hard to interpret, but we at least have a sense of what the cutoff would be when I decide, what, you know, when I make a decision on like specificity is more important than, precision or recall or whatever's most important. This gives me an intuition on what cutoff value am I picking? And so then off of the performance object, I can get a data frame for me to be able to get this. Uh, I really like this because it's kind of a pain in the neck to get this information out. I have to go use str to look at the object, see what the slot names are, see what the structure is, and pull it out. I don't have to. I just go and I get it. When I use Fortify. Yeah, we just keep on going with this um, with an LFDA model. And so here it does a principal component analysis plot for us. Very nice. And here, here's the original data. Here is the principal component, so we get everything all together. And we can auto plot the B-spline basis for polynomial splines. I know a lot of strong math people that do a lot of stuff with splines. I don't usually use splines too much. I've sat in on plenty of talks about splines, but here we can see like this is visualizing what the polynomials look like for us, and at the points of that we're basing the spline off of. And we can get like the output of the X and the Y. Now for clustering, so I've taught data mining 2 a lot. We do a lot with clustering. The autoplot function is super helpful in this, in that what it does for me is I get that principal component analysis plot spit out easy peasy lemon squeezy, and I get to know what percentage of the variance is accounted for by each principal component. We can see that PC1 is accounting for a lot, PC2 not as much. And we can see that the clustering is pretty much in regard to PC1, which is not surprising. That's typical. And the fortify just extracts the cluster function or the cluster assignment for me, so that way I can get it. If I wanted to, I could easily tack that on to the data frame of the original data. All right, so now we're going to look at 3 different cluster models from the cluster function or cluster package. So Clara, clustering large applications. The cluster package loves women's names. So first one's going to be Clara. This is a good choice for a big data problem. I think it works comparatively to k-means. To my eyes, it looks like a variation of k-means. Um, but when we do our auto plot, I have the option to put label equals true, and it's going to label the original data point. So this is going to be the row name of each one as it's plotted. So it gives me an ID. I can figure out what's going on easier. Fortify. Now, with Clara, in contrast to k-means, is it takes the original data and tacks on the cluster for me. I can also plot the silhouette plot. So on a silhouette plot, if I see a bar going to the left, that's indication that a point is closer to its closest neighbor is outside of its cluster, which means it may be misclassified. It's just a diagnostic. It's a maybe, maybe not. The farther to the right the bar is, the more confident I am on the individual data point being in the right group. All right, and so here, if I want to, go a little bit deeper, and this is one of my complaints of the silhouette function in the cluster package, is that it's hard to tell which one's which off of this. When I use Fortify, real easily, I get the ID of the variable, so that's the row name of it, so I can find it. Here's a silhouette width. I can, spot the ones that look problematic, and I know which cluster it's in very easily. Now we can also do auto plot fuzzy analysis clustering. So this is Fanny. And on Fanny, there it's going to give like a probability of belonging to a particular cluster. And once again, I can label equals true, and it does the principal components for me. Very nice, very easy. When I do fortify, I get cluster packed onto my data frame. Silhouette, easy peasy lemon squeezy. Now here, what this tells me is that these are closer to their closest neighbors are outside of their cluster. That may be all right, that may be a problem. We know it's green, so that I know it's going to be one of the points along the boundary are going to be these guys here on the silhouette plot. And I can once again get my silhouette information out using Fortify, easy peasy lemon squeezy. And we can also do partitioning around the medoid, PAM, and I get the same utility over and over and over, you know, working through this. Now, if I put frame equals true and frame type equals T, it will go ahead and put the normal distribution ellipses on there for me. And so this is these ellipses are like 95% confidence ellipses, capturing approximately 95% of the data, if it's a good model fit, at least. And we've seen this a bunch of times. I'm just going to scroll down. All right, dimension reduction. All right, so I found 3 different dimension reduction techniques supported by ggfortify: PR comp, print comp, and then factor analysis. All right, so PR comp is the one that's numerically more stable. It doesn't have as many features for support as print comp. So if I'm doing something like psychometrics, I'm probably going to use a print comp. I've never seen a problem with numerical stability, but from a strict hard science point of view, PR comp is the one that's going to be more stable. They my experience is they slightly present different things. Like they give you the same values but packaged differently is what I have observed. And just like I saw before, I can do principal component analysis, boom and boom. How much variance are we accounting for is presented off of this, and this is off of the original data. This is not off of the cluster. So previously we were looking at principal component plots, and the label was the cluster, not the actual data. Now I'm looking at the actual data itself. And so this, remember that in this region here was where that clustering, like they were, it was like green and blue and they were right up on top of each other. Well, we can see that's because we got things mixed up in this region. And I have a lot of features for being able to do an auto plot, and we can even do our biplot for us very easily. There's a lot of things to do, a lot of things I can put down on this to better understand. All right, so principal component 1. So I'm looking at this, and this is picking up petal length, petal width, and septal length. And septal width is not as important. All right, so when I look at this, this is overall, I would say PC1 is the overall petal width, like petal size and septal length. So this is like the overall size of the flower. And then septal width is, you can see that it's really the only one that's going along with PC2. And so PC2 to a large extent is capturing the just septal width by itself. Kind of an interesting factor analysis off of that. Now, when I do fortify, this is so nice in that it just goes ahead and puts my principal components on there for me immediately, and I have it in a nice spot, easy to work with. Now with print comp, I'm pretty much doing the same thing. It's just slightly a different object. Now notice that the points are going downward like this, and the points are going upward like this. Remember, if I multiply principal component by -1, mathematically, I have an equivalent from the math point of view of construction. I have an equivalent principal component representation of my data. And so multiplying by a negative sign can change our interpretation of things. You have to keep that in your mind if you're doing factor analysis. Um, Mathematically, they're picking up the same information, but if I multiplied PC1 by a -1, I'd be reflecting horizontally. From a math point of view, I've got the same information captured. It's just being presented differently. And so here, once again, I can do a more comprehensive plot. And you can see that PC2 has been multiplied by -1 compared to the PrenComp version. Fortify does the same trick for us. Now for factor analysis, we can do the same thing once again. It does a principal component plot. Well, actually, no, it doesn't do a principal component plot. It takes the model that we have. So when we do, so how I set this up is that I'm going to go, do factor analysis. Here I've got three factors, and I'm going to do the scores based off of regression, and I can control these parameters in other ways, and this will show me visually what do I have off of my factor analysis. This is similar but different to principal components. Factor analysis is trying to find latent variables that drive the variables that I see. So think about intelligence and performance on a test. I can't actually observe intelligence, but I can observe performance on a test. I'm inferring that there is intelligence driving the results of the test. Factor analysis is trying to quantify that intelligence based off of the observations I have. And we can do our auto plot, and I can choose a variable to color by. And so you can see life expectancy is pretty well correlated with factor 1 going on. You can see the light blues are on the right, the darkers are on the left. And we can go through and plot. So here we've got a bunch of things. So we have murder, illiteracy, population, area, income, high school grad, life expectancy. And so illiteracy and murder are bad things, while income, higher high school education, and life expectancy are good. And so factor 1, to my eyes, is picking up like what is the overall like life quality of the individual state. Now, factor 2, we see frost is sticking out and illiteracy is sticking out. But you know what? Frost is so different. I'm going to just say that factor 2 really is just picking up the frost aspect. You can see like warmer states are up top here. We have North Dakota down here. Wow, Nevada. I wasn't expecting that position given frost. Um, Interesting. And now for Fortify, it's very nice in that it spits out the factors for us. All right, so now for spatial statistics, ggfortify does a good job of just basically giving me a quick, easy plot where I don't have to fuss with things. All right, so if I have so something that you have to be mindful of is that when I use ggplot and I use the autoplot function, what it's going to do by default, it's going to work to zoom in on what's going on. All right, so if I have a map and I have a much wider plot area than I do vertically, what it's going to do by default, and this is true for ggplot, this is true for autoplot, it's going to zoom in by stretching in the east-west direction. And what that does is that's going to screw up the interpretation of my model or my map. And so what I can do to correct that is coordinate is SF, and what that or chord fixed will also do this frequently, is that this will solve that problem. It'll say, hey, this is a map, present this as a map, don't stretch things to zoom in. Even if you don't have to use the full area. So there's the state of Florida, counties. When I do fortify, this will go and break up the subregions for me that I have. And the polygons, and it will give me the information about each individual latitude and longitude point. Also, this will convert raster objects very nicely to an image. And if you look at my videos on spatial statistics, I have gone over this data set a lot. It's in that textbook quite a bit. And so we can quickly get an image going on off of it. And so, rasters are kind of a pain in the neck to work with. Here, I'm saying, hey, don't give me anything if it's a missing value. And now we can also do spatial polygon data frames. So most SF objects are well supported by autoplot. Just remember, I almost always want to make sure that I have coordinates for a map object. And so boom, I've got my polygons. And by putting it as gray, what I could have done if I would have had data that specified like high school graduation rate or income or life expectancy, something like that, I could plot each individual county a different color to help me interpret. And once again, I can get information on the spatial polygons. And we can also convert a distance matrix to a data frame. We could also just use as.data frame off of instead of Fortify, but yeah, no, it's nice. It does a good job of setting up the row names and column names for us. Survival analysis are right. We're on the last stretch of this video. For survival analysis, I can auto plot this. So notice that I've got age, sex, and PHE cog going on. I've got my age, I've got intercept, I've got sex, I've got PHE cog. So I can analyze my survival analysis very nicely. And it makes it pretty easy to be able to get the age, sex, and pH, the cog aspect of the model out. We can also visualize our survival objects. Basically see the same thing that I have a survival object. I'd like the features of it to be in a data frame, and Fortify delivers for me. And we can separate this out that if I have two different strata, I can do that. I can also break up the strata by using a faucet equals true. And I can drop the sensor aspect. I can drop the confidence interval if I wanted to look at just the central point estimates. We can do proportional hazards regression model, real easy peasy lemon squeezy. Good, fundamentals on there. Now, other things that we can do, we can also plot densities real easily for us. So here, I don't have to do the intermediate step of computing a density. I can just take some data, I estimate the density, and then I drop it in there. So I've got visualization of the density. I can also fill it in to change up the colors. And the Fortify will actually go and give me the distribution's estimated value. And then we can auto plot a matrix. And so this will go into each row, each column's entries. And you can see here's the columns, here's the row. And I can see maybe I have a pattern in my matrix and be able to find what's going on. We can also do an auto step function. And this is as simple of a step function as I could come up with. Just take a look at the visualization. And we can have a multi-dimensional table converted to a data frame. That came up in the previous video that I posted. So this is real nice and easy. You could also as data frame to perform this. One thing that is a pain though is that we'll get frequencies of 0 when for a table that has for tables combinations that aren't present in there. And that's maybe I want that, maybe I don't. In my visualizations, I don't want a frequency of 0. when I'm using a table counts. And back transform scaled object. So this is just, unscaling a scaled object to show the original result. All right, that's all I've got. All right, so ggfortify has a lot of utility. This has been a long video. Thank you for sticking with me. Um, if you want a quick and easy plot without having to fuss with it, AutoPlot's got your back. If you want to be able to extract things from an object without having to fuss with what is the slot name and the structure of the object, Fortified has your back. All right, well, that's all I've got for you. Life is short. Do math.